Hi, everybody. Before we start talking about how to find area and perimeter on the coordinate grid, just a couple of reminders. So, number one, if I want to find the area of the shaded region, one thing that I can do is I can find the area of the whole and subtract away the area of the unshaded to be left over with the area of the shaded. So, I'm going to write that down: whole minus unshaded equals to area of the shaded region. So this is 1, 2, 3, 4 by 1, 2, 3, 4, 4 by 4. So the area of the whole is length times width, that's 16, minus the area of the unshaded part. So the unshaded part is a triangle. So the area of a triangle is equal to 1/2 base times height. And since this is a right triangle, it's really easy to see that the base and the height are the legs of the right triangle. So the base is 1, 2, and the height is also 2. So the area is 1/2 of 4, which is 2. So we have the area of the shaded region is 14 units squared. We can use the same idea over here to find the area of the shaded region. We can do whole minus unshaded, and that's going to give us the shaded region. So the whole thing here is a circle. So area of a circle equals to pi radius squared. So the radius is halfway across the circle from the end of a circle from the circumference of the circle, I should say, to the center. So here that's 1, 2, 3. Yeah. 1, 2, 3. So here the area of the circle is pi 3 squared, or 9 pi. So we have the whole minus the unshaded, that's a rectangle. So that is 2 by 1, 2, 3, 4, 2 by 4. So that's minus 8. So the area of the shaded region is 9 pi minus 8 units squared. So it's kind of easy to find the area when we have like a shape that we're familiar with. For example, in A, we had a large square, and then inside we had a right triangle, both of which we have area formulas: length times width for the square, 1/2 base times height for the triangle. Same thing for B. We know how to find the area of a circle, it's pi r squared, and we know how to find the area of a rectangle, it's length times width. So calculating those areas were pretty simple. Now, when we get to examples where it's not so clear what the formula would be, that's when it gets a little bit tricky. Take a look at this triangle, for example. So on this triangle, I'm going to do the area first while we're on the topic of area, and then we can cycle back to perimeter. So if we're finding the area of this triangle, we know that the area of a triangle formula from before is 1/2 base times height. So it's pretty clear to see that the base is over here. It's 1, 2, 3, 4, 5, 6, 7, 8 units long. It's a straight line, so I can count the boxes. But the height is not so clear. The side of the triangle is not the height. This is not a right triangle. You can think of height as the altitude, and that's a perpendicular line through the opposite vertex. So the opposite vertex to the base would be here. So a perpendicular line straight down would be right here. So this would actually be the altitude or the height of the triangle from the very top to the very bottom of the triangle. And that would be 1, 2, 3, 4, 5, 6 units long, the height. To find the area of the triangle, it would be 1/2 6 times 8. So that would be half of 48, which is simply just 24 units squared. So if you didn't recognize that the altitude was a perpendicular line through the opposite vertex from the base, you might have ended up with an incorrect area trying to use the regular area of a triangle formula. So we're going to do this a little bit differently, and you're going to see we're going to arrive at the same answer, but we're going to use a method that works regardless of what shape you have, as long as it's on the coordinate grid, in order to find its area. And it's super useful when you're dealing with a triangle where you don't really know what its base or its height is, and you don't want to use the wrong thing by accident. Or when you're dealing with a shape that's something, irregular that you haven't seen before, and there's not really a formula to find the area of it. This method will be super useful. So what we're going to do first is I'm going to draw a box around the triangle. And when I draw a box, I want to make sure to connect from vertex point to vertex point. I want to completely enclose it. So let me go from vertex point to vertex point. The next one's over here. Let me go up. Notice how I'm connecting through all the vertex points. And then there. And I've completely boxed the shape. And now what I can do is I can do what we were doing in the first slide. I can do the whole box, the area of the whole box, minus the area of the unshaded region. And that should give us the shaded blue triangle that we're interested in. And the reason why this is going to be useful is because we know how to find the area of the whole box. It's length times width. And the unshaded part is right triangles. And with right triangles, it's really easy to find that area because we know what the base and height is. The base and the height are always the legs of the right triangle. So there's no confusion as to what plugs into 1/2 base times height when you have right triangles. So let's try it out. The whole box is going to be 1, 2, 3, 4, 5, 6. And this was 8. 1, 2, 3, 4, 5, 6, 7, 8. So 6 times 8, that's 48. Okay, now let's find the area of the unshaded regions, which are the triangles. So we have right triangle number 1 and right triangle number 2. So the area of triangle 1 is 1/2. The base is 2. And the height is 6. So that is 6. Half of 12 is 6. And the area, that was supposed to be an A for area. Area of triangle 2 equals to 1/2. The base is 1, 2, 3, 4, 5, 6. And the height is 1, 2, 3, 4, 5, 6. Half of 36. And half of 36 is 18. 18 plus 6 is 24. So the unshaded region, the area is 24. And 48 minus 24 is 24 units squared. So notice that we arrived at the same answer that we did originally. And in this case, yes, it might have been a little bit more work to use this method, especially if you realized where the altitude was at the beginning and you knew that that was the height of the triangle, but a lot of people don't. We'll see in the later on examples in this video that sometimes base and height is not clear. Sometimes you don't have the formula, and this method is really useful. Just to talk about the perimeter. Perimeter is just the length of all of the sides of the shape added together. So we know that this side of the triangle, the base, the flat side, is 8. But the other two sides of the triangle are slanted lines. So we are going to have to use the distance formula to find the length. So let me see what this is. So this was 2/8. This was 10/8. And that one was 4/2. Just writing down the points from the question. So let me pause the video and I'm just going to find the length of the sides using the distance formula. And using the distance formula, I calculated the lengths of the two other sides of the triangle. The side over here was radical 85, and the side over here was radical 72, which simplified to 6 radical 2. If your radicals don't have the same number under the radical, you can't add them. They're not like terms. So my perimeter of the triangle would be 8 plus radical 85 plus 6 radical 2. Okay, So here we see where our new method for finding area could be really, really useful, because looking at the shape, I see it's 1, 2, 3, 4, 5-sided, so it's a pentagon. I don't really know how to find the area of a pentagon. I don't have the formula for that. So what I'm going to do is I'm just going to enclose it completely in a box. And I just want to make sure I get all the vertex points in my box. And look what happened. I have 2 right triangles here. I'll label them triangle 1 and triangle 2. So the whole is 1, 2, 3, 4. 1, 2, 3. So the whole is 4 times 3, which is 12, minus the area of the unshaded. So this one, so the area of triangle 2 is 1/2. The base is 2. The height is 2 as well. So half of 4 is 2. And the area of triangle 1 is half of the base is 2. The height is also 2. So it's half of 4 once again, which is 2. So the area of the unshaded region is 4. So that brings the area of the entire shape to be 8 units squared. Okay, next one. Oops. Trying to completely enclose this in the box because we are finding the area. Want to get all those vertex points in my box. There we go. And look what happened here. Not only do I have 2 right triangles, 3 right triangles, but I also have a square, which I definitely know how to find the area of. So the whole is 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 times 4 is 20. Minus, let me find the area of triangle 1. So that's 1/2. The base is 1. The height is 2. Half of 2 is just 1. Next is area of triangle 2. Once again, it's 1 by 2. So the area is going to be the same as triangle 1, which was 1. Triangle 3 also has the same measurements. It's got a base of 1 and a height of 2. So that means the area of triangle 3 is also going to be 1 because we're plugging the same things into the formula. And then finally, the area of the square, it's a 2 by 2 square. So the area is 4. So altogether, 1 plus 4 plus 1 plus 1, that is 7. So the area of the shaded region is 13 units squared. Super quick method to find the area of any shape on the coordinate grid. Okay, moving along here. So finding the area and perimeter. So you might want to pause the video and try to find the area and perimeters on your own. It's a little hard to see the coordinates here, but definitely for the area, you might want to pause the video and try it out. So, oops, thought I had my line. Okay. There we go. So the whole thing is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the whole thing is 25. 5 times 5 is 25. This triangle right here is half of 1 times 2. Wait, 1, 2, 3. 1 times 3. My bad. And half of 3 is 1.5. Okay, this triangle over here, that's half of 1, 2 is the height. The base is 1, 2, 3, 4. So half of 8 is 4. This triangle over here is half of 1 times 1, 2. So that's half of 2, and half of 2 is just 1. And finally, this last right triangle over here, that is half of 2 times 3. 1, 2, 3. So that's half of 6, which is just 3. So altogether, we have 3, 4, 8, 9.5. So the area of the shaded region is 25 minus 9.5. That is 15.5 units squared. I'm not going to do the perimeter on the video. You can pause the video and you can find the lengths of all the sides using the distance formula if you choose to. Perimeter is just distance formula, which we've done so many times. And finally, the last one that we're going to do for this video, I'm going to just completely enclose. This one's a little difficult. Okay, completely enclosed it. And notice over here, I can break that down into 2 right triangles and a square. So I have a total of 4 right triangles here. That works. So the whole thing is 1, 2, 3, 4, 5 by 1, 2, 3, 4. So that's 20. 5 by 4 is 20. Okay, this triangle first. So that's 1/2 of 1 is the base. 1, 2, 3, 4 is the height. Half of 4 is just 2. Now I'll do this right triangle next. So half of 1, that's the height, times 1, 2, 3, 4, 5. So half of 5 is 2.5. Okay. This one over here, so that's half of 1 times 2, so that's half of 2, so that's just 1. And over here, oops, I don't want to get into my other thing I had here. So that's half of 1 times 1, 2, 3. So half of 3 is 1.5. And then the square is a 1 by 1 square, so the area is just 1. So let me add the areas of these right triangles and the square together. So the first square was 2. The second square was 2.5. The third one was 1. The fourth one was 1.5. And then the square was 1. So that's 8. So what I have here is 20 minus 8, and that is 12 units squared. And there we have it.